I'm James Hortop from Merlin Equipment, and I'm here to speak to you today about our new PowerCell lithium-ion battery. The Merlin PowerCell Lithium 100 Ah battery is the only deep cycle lithium battery that's made here in the UK. The main differences between our lithium batteries and a conventional leisure battery is that almost all of the battery capacity within the battery is usable. You can actually pull out 100% of the rated capacity of the battery for running your onboard loads. Very importantly, what's different with our batteries compared to many of the other batteries is the output voltage is very, very stable, so it's absolutely perfect for running sensitive electronics like inverters and various other items like that. Our battery also has a 5,000 cycle life. As you can see, it's very light, it weighs just 15 kilograms. Importantly, with the Merlin PowerCell battery, the BMS, the battery management system, is actually built in within the battery. The battery is completely independent. There is no need for any external contactors, any external controllers or electronics whatsoever. Perhaps very importantly for critical use applications, it means that there are no communication cables between this battery, other batteries in the bank or an external BMS. In the event of one of those communication cables becoming detached or having a poor circuit, the battery bank in some circumstances can shut down completely, which is not very good for a critical use application or when you're out sailing across the middle of the channel. With the PowerCell lithium batteries, in the event of one of the batteries shutting down in a bank, the rest of the bank will continue to operate. The battery is manufactured here in the UK within an ISO 9001 facility. Very, very importantly with lithium ion, this battery is UN 38.3 approved. It is also approved for IATA requirements for international air freight. It meets UL 1642, IEC 62133, UN 3480 and is CE approved. The cells within the battery are very, very high quality, which give you a very, very stable output voltage even under high current. This battery, this 100 Ah battery, is capable of giving you up to 100 amps continuously, up to 150 amps for short periods of time. That means that if you've got, say, two batteries in parallel together, that bank would give you 200 amps continuously, or 300 amps for short periods of time as well. So today we're going to be testing the Merlin PowerCell 100 Ah lithium-ion battery. The test rig that we're going to be using, it really simulates a work van. It's going to be used out throughout the day. And basically what we've got is we've got an inverter and various different test loads to operate from the battery. Now normally you wouldn't really run a 2000 watt inverter from a 100 amp battery on its own. It's quite incredible to see really what this battery can do. Basically what we're going to do is simulate a day's work in that van. So starting off with running the microwave for 5 minutes. That's a 700 watt microwave, and its input power requirement is actually 1200 watts because the heating power and the input power for the microwave are two different things. So we're going to operate the microwave for 5 minutes. We're then going to run a toaster for a cycle to sort of simulate getting going in the morning. We're then going to run a 500 watt load for 40 minutes. We're then going to run the microwave again, simulate a coffee or a lunch break for 5 minutes. Our 500 watt resistive load again for a further 40 minutes. Then 1000 watts resistive load for 10 minutes. Then we're going to run a power tool for 2 minutes, back to running our 500 watt load. We're going to run that continuously until the batteries are depleted to see really how many ampere hours you can get from the batteries. The recommended charging current is 50 amps per cell, however it will accept up to 100 amps, and again if you've got multiple batteries in parallel you can add to those numbers. Okay, so the test rig that we have is we have one of our 100 amp PowerCell batteries already set up here. I've already pre-charged this battery, so the battery is right up at 100% charged. Fitted to the top of this is one of our TBS Expert modular battery monitors, which is a battery monitor specifically designed for lithium-ion batteries. The gubbins for the battery monitor are actually on the top here, which is a separate module. All of the negative current for the battery has to run across the shunt module at the back here, which is how the unit monitors the current going in and out of the battery. So what we've got is the battery monitor display here. The larger number at the top is the state of charge of the battery. It's showing that we've got 100% state of charge at the minute, so we've got 100% of the available ampere hours available from the battery to pull down. Now, normally we wouldn't recommend you pull 100% of the ampere hours out of a battery because it does shorten its life. Normally with a lithium battery, you'd only take about 80 or 75% of the stated ampere hours out of the battery. So you will see this display go all the way back to 0%, and we're still continuing to operate later on. The smaller number, we can see the battery voltage. We can show the amount of current that we're pulling down from a battery. So currently 0.02 of an amp, which is just these electronics running. How many watts are coming from that battery. How many ampere hours we've pulled out. So the target of during this test is trying to pull 100 ampere hours out of the battery. How many hours we've got left running at the current rate of consumption so the battery is flat, and back to voltage again. So this is a very important piece of equipment for this test. And importantly, the battery is fully charged at 100%, so all synchronized up with the battery. The other piece of equipment that we've got is our KISSE 2000 watt power inverter. This is a pure sine wave DC to AC inverter. We supply many of these for service vehicle fleets, ambulances, fire engines, police cars, etc. Very reliable inverter. On the front of it, if I switch her on, it will show us the battery voltage that we're putting down, and it will show the amount of power that we're pulling from the batteries as well. This is connected using these two heavy duty cables at the back of the inverter up onto the battery itself. You'll notice we've also got a clock. We've put a clock on here which I'll set to midnight in a moment, so that we can keep a track on the time and how long we're actually operating some of these loads for. Importantly, with the inverter has a low battery shutdown on it. Once the voltage is down to about 10.8 volts on the input, it will shut itself down and give us a long audible warning. And that's going to be our cut-off point, because we know it's a fixed number. And really, once the battery is below that level, the power isn't really usable, and most of your electronics on board will shut down. Okay, so our test is about to commence. I've set the clock to midnight, really just to give you an idea of what our general time is. So what we're going to do is we're going to run the microwave now for 5 minutes. So I'm going to put this on right away. It obviously has a big mug of water in there to stop things overheating. So if we have a look at the battery monitor now, what we can see is the voltage has dropped. It's obviously an extremely heavy load, 1200 watts. From a 100 ampere hour battery is quite a large number, but the voltage is still steady at about 11.5 volts, and that's very important because it's allowing the inverter to operate correctly. We can still see we're pulling 111 amps continuously down from the batteries, and there we are, 1275 watts. As I stated, 700 watts is the heating power of the microwave. It's going to pull about 1200 watts plus inefficiencies of the inverter and things like that to actually convert the power from 12 volts up to 230. And you can see the amount of ampere hours that we're going to be pulling from the battery. So the microwave is still operational. It's been running for 5 minutes now. You can see the voltage is still stable at 11.5 volts. We're still using 103 amps in the batteries. About 12 ampere hours down from the battery. So we've used actually about 10% of the stated capacity of the battery itself. So just before this finishes, I'll be grabbing our next load, which, as we said before, was a toaster. So I'm going to plug the toaster in. We're just waiting for the microwave to finish. The toaster's ready. Our toaster is a 700 to 800 watt toaster. And any second now, the microwave will finish. And you see we've still got nice steady voltage. And we've now used about 15 ampere hours from the batteries. Okay, so now we're going to run the toaster. So we'll put this on for one cycle. So the toaster's now running. You see we're again pulling a fairly heavy load. So we're drawing 71.5 amps from the batteries, 860 watts. And we're operating the toaster. So I'm going to unplug the microwave for the time being. And our next load is one of our very basic test fixtures from our workshop, which is two 500 watt halogen bulbs, switches to switch them on and off, and a plug on the end. So I'll just set that up while we're waiting. Okay, so the toaster should go any moment. You can see the voltage is still now 12.1 volts, still nice and stable, and that's pulling 70 amps continuously. Okay, so the toaster's now switched itself off. The voltage has recovered back on the battery right up to 13 volts. And we have pulled a total of 20 ampere hours from the battery. So that was running the microwave for a full 5 minutes and the toaster for a full cycle. So moving now across to our resistive load, So in the case of our work van, the chap has, or the lady has started their work day, used a microwave, created themselves some breakfast or snack, whatever. Now they'll be running some site lamps or recharging some power tools, etc., which is what our resistive loads are going to emulate. So we're going to switch that on now. It's going to be very bright. So we've got a 500 watt halogen lamp on now straight away. And what you'll see is the power that we're pulling down from the battery. And we're going to be operating this now for 40 minutes. So the clock will be showing 12:52 by the time we've finished. We have a steady battery voltage of 12.66 volts. We're pulling 36 amps down from the batteries, 458 watts, and we've used so far 20 ampere hours out from the batteries. And I think it's very important to mention at this point in time, this is really where a lithium-ion battery works very well. They're okay at the very high levels, and they're very impressive at high levels. But where they work really well is that medium power and running it for a very long period of time. So we're going to be running this 500 watt halogen bulb now for the next 40 minutes, and we'll check back in 40 minutes time. Okay, so as you can see from the clock, we're now approaching 40 minutes. So for the last 40 minutes, we've been running this 500 watt halogen continuously. The voltage is stable at 12.4 volts. We're still pulling our 36 and a bit amps, 454 watts. And we've used 43 ampere hours from the battery, so approaching approximately 50% of the available capacity from the battery, which incidentally is normally where you would discharge a normal leisure lead acid battery too. So really everything that we're getting now is a bit of a bonus. So what we're going to do is, we're just coming up to 40 minutes now, so I'm actually going to disconnect the light. It's rather bright. The toaster's still plugged in. We're going to get the microwave plug back in again, and we're going to run it for 5 minutes. So this is simulating in the back of our work van lunchtime. The microwave's just about to stop, and the alarm has literally just sounded. So we can see now that, I'm going to say any second now it's going to stop. The voltage is down at 11.2 volts, which is about right for the alarm to come on the inverter, but it's still stable, pulling 100 amps. We're still putting on 1200 watts, but we've used 54 ampere hours down from the batteries. So now what we're going to do is just wait for that microwave to stop. We're going to put the light loads back on for 40 minutes, so a 500 watt load for 40 minutes. What's important here is that now that the inverters, so the microwave is finished, the voltage is recovered back up to 12.9 volts. So now we're going to put a 500 watt halogen on. Now, one of the things you may be wondering is, I've been having to sit around for 40 minutes while waiting for this thing to run, and how you keep an eye on what's going on. Well, the way I'm doing that is that with the battery monitors, that we actually have a Bluetooth device that we can use. This is the Bluetooth dongle, so I can plug this in. The Bluetooth is now active. I can go to my phone, and I can go to the TBS Expert Modular app, and this app will show me the voltage, the current, how much time we've got left on the battery, plus a whole load of other information like the state of charge, voltage, current, time left, status, the power, ampere hours and temperature of the battery. We've also got within this, in the settings mode and history, it will show us the average depth of discharge, average discharge percentage, deepest discharge, deepest ever discharge, total ampere hours removed from the battery, a whole load of information, including the battery state of health. So this is a very useful app that we use. So going back to our test now, it's just past 1 o'clock on the clock up there. We have removed 54.4 ampere hours from the battery. So essentially the battery is at about 50% depth of discharge at the moment, and we're going to put our 500 watt load on. Put the other one on. There we are, 500 watt load. So we're going to return back here in 40 minutes time to see how the battery's holding up. So we're about 20 minutes through our 40 minutes run. I just wanted to show you we're just about to receive a state of charge reading on the battery monitor of 0. So we've pulled 65 ampere hours out of the battery. our test will continue, and we've got about another 20 minutes of running the light before we move on to the next phase. So 40 minutes is up. The 500 watt halogen lamp is still running at this point in time. The voltage is steady at 11.95 volts. We've removed 78 ampere hours from the battery, so there's only 20 ampere hours left in the battery at the minute. Now what we're going to do is we're going to switch on a second halogen lamp for 5 minutes. It might bring the alarm on the inverter, but we're really asking a huge amount of the battery at this point in time to now start pulling 1,000 watts from it. And as you can hear, the alarm has come on. The voltage is steady though, at 11.2 volts. We're putting 70 amps down from the batteries, and we're going to see if it will run that now for the next 10 minutes. So looking at the clock, we'll be at 52 minutes past. Okay, so we're at 52 minutes past now. We've been running the 1,000 watt load for 10 minutes. You can hear the alarm, the inverter is running. The voltage is down at 11 volts, but we've been asking a huge amount of the batteries. We've pulled 89.5 ampere hours out of those batteries, so 90% of the power out of that battery we've pulled, which is really very, very impressive indeed. We'll turn these off now. So bearing in mind at this point in time, we've run that microwave for 10 minutes, we've run a cycle of the toaster, we ran 500 watt halogen for 40 minutes, we then ran the microwave for another 5 minutes, we then ran the halogen again at 500 watts for 40 minutes, then 1,000 watts for a further 10 minutes, and we've used 90% of the battery capacity. So let's say we want to do a little bit more work at this point in time, and we used a slightly different load. And that load was a 750 watt angle grinder. Now bearing in mind this is an inductive load, so it requires a good surge of power to actually get it going. And we're going to run this for 2 minutes, and it's 2 minutes on the clock, which I'll start it up now. It's going to be noisy, so we'll cut to the end of this shortly. That's just been running that continuously for 2 minutes, but it's the start-up that really takes the grunt. So if you start it a few times, and you can see the battery is still capable of providing that surge of power. You can see on the battery monitor here that the voltage is still level at 11.5 volts, 1.4 volts. We're putting 40 amps down from the battery. We've used over 90% of the battery capacity, which is really quite impressive at this point in time. But we're going to ask more from the battery, even more at this time, and that's we're going to run one of the 500 watt halogen lamps now continuously until the inverter goes into full flat battery protection mode. So just having a look at the time, it's showing approximately 3 minutes to on the clock. I'm going to put the halogen lamp on, and we'll wait and see how long we've got until the battery runs flat. Okay, so 13 minutes in, you can see we've pulled 99.7 ampere hours now from that battery. So we have fully exhausted that battery, and it's really impressive to be able to pull 100 ampere hours out from the battery itself. We should see the voltage now starting to collapse. It's down at 10.7. You can see it's going down all the time. Inverter should switch off imminently. 99.9 ampere hours. Come on, you can do it. 99.9 ampere hours available from that 100 ampere hour battery. Well, I think we'll settle with that. It's extremely impressive. We're now going to recharge the battery in fast order. The maximum charging current for the battery is 100 amps. The recommended charge for the battery is 50. We're going to put it on one of our 60 amp battery chargers. So I'm just going to disconnect it here, take the battery across to where our charger is installed. So now we're going to charge the batteries, and we're going to be using one of our AVSO 60 amp 3-stage smart battery chargers to do the job. Quite importantly, the way that the battery charger operates is that it uses a 3-stage smart charge, which is designed specifically for specialist types of batteries like the lithium batteries in this case. The 4-stage charging provides the full output of the battery charger continuously until the battery is about 80% charged. then the voltage is held constant, the internal resistance of the battery starts rising, so the current drops back until the battery is 100% charged here at the end of the absorption mode. After that, the battery will sit in something called float mode, where the charger can be left connected 365 days a year if you want to, without the battery going flat, so it will maintain it. Our battery chargers also act as a power supply as well, so it means that while you're on board your boat or in your RV, you can run lights, televisions, all of the various different DC consumers on board without the battery actually going flat. So within the system we've got set up for charging here, we've got the battery, which is just down on the ground here, sat with our battery monitor so we can see what the state of charge is, and we've reset the clock as well. So now I'm going to start the battery charger and we'll start charging. So we've now switched the battery charger on, and as you can see from the display on the charger, we are delivering a full 60 amps down to the battery. So this will operate continuously now until the battery is about 80% charged, pulling that full 60 amps for a very quick and rapid recharge. Importantly, the BMS within the PowerCell battery will only pull the amount of power that it is safe to recharge that battery at. For example, in this case, it's pulling the full 60 amps, which is the maximum current that we can deliver. However, if the battery is very hot, it will only pull, say, 40 amps or 30 amps, i.e. it will only pull what is actually safe. So we'll return now in an hour or two and we'll see how the battery is doing. So we've been running for about an hour and 20 minutes now. The battery charger is still producing quite a lot of current. It has actually backed off a bit to 36 amps. You can see from the clock, we've been running for an hour and 20. And if we zoom in onto the battery monitor, the monitor will show us that we've got 30 ampere hours to replace into the battery. If you remember from earlier in the video, it's not worth looking at that percentage figure because we actually took the battery right down to 100% depth of discharge, and the discharge floor set up on the battery monitor is different. So an hour and 20 minutes in, and that battery has taken almost 3/4 of its capacity. So 45 minutes later, the battery is now almost fully charged with just 7.9 ampere hours to replace into the battery. You can see on the battery charger it's reduced its charging current quite significantly. We're in absorption charge mode, which is a large charge mode with 24 amps going into the batteries. So very shortly the battery charger will finish charging. So we're coming up on 2 hours 40 minutes. We can see from the battery monitor that we have got just 0.6 ampere hours to put back into the batteries, so it's pretty much fully charged. The charger's dropped into float mode, so within less than 2 hours 40 minutes we have been able to fully recharge that battery. So that concludes our test of the Merlin PowerCell Lithium 100 ampere hour battery. It's the only battery built here in the UK, 100 ampere hours. You can pull up to 150 amps from the battery and you actually use all of the 100 ampere hour capacity of the battery. The unit charge is faster than a standard battery, and of course it's only lightweight at 15 kilos. We provide the battery with a 5,000 cycle 7-year warranty, and be very happy to talk you through it if you give us a call on 01202 697979. Our studio remains set up here in Exeter at all times, so if you'd like to come down and physically see one of these working, you're very welcome. Alternatively, take a look at our website, www.merlinequipment.com.